change the air temperature in the atmosphere. How? How then can we change the air temperature, because our principal focus is our environment, our atmosphere, what is going on over there? How? There are ways by which temperature in the atmosphere changes, which is our next discussion. Sorry, I'm supposed to go forward. We can only achieve this in two ways. There are two ways to achieve changes of temperature in the atmosphere. The gas temperature, not just the gas temperature in the atmosphere. One, by adding it to the air person, or removing it from it through diabatic. I mentioned diabatic process. Alternatively, we can add it to the air person or remove it from it through adiabatic process. So these are the two processes, diabatic and adiabatic processes. So a thermodynamic process or change of state of a system in which the system exchanges its energy with the surroundings or the environment by virtue of a temperature difference between them is called diabatic process. When there is exchange of its energy with the environment through thermodynamic process, and then there is a difference in the temperature between that process and the environment. The system is called diabatic process. Do you understand now? You picture our environment, picture our atmosphere, picture our surroundings, and then relate it to this statement. Thermodynamic process says a change of system. By the time the system exchanges it with the surroundings or environment. And what happens when there is change of heat? It is change of temperature difference that causes change of heat. Do you understand? Difficult or what? The class is so silent. If you don't understand, just don't worry. We are learning together. You can always ask questions. Don't be too shy to ask questions. This is discussion, not examination. Only in the exam that cannot ask questions. But now you are free. You can discuss. You can refer to anything. So, but don't forget that all our discussion on this subject is related to our atmosphere, our environment, our surroundings. Now, just relate it. So, this is the diabatic process. When we have the processes that involve diabatic. Now, the other one is adiabatic. So, these are the two things we now discuss into details in the next slides. Now relating it to our surroundings. These are examples of diabatic processes. We have rain clouds, cloud formation, evaporation from the ocean, transpiration from the land and the ecosystem, precipitation again, then the soil, the groundwater. So this process is what we call the diabatic process. When we have gaseous water in gaseous form or from the ecosystem and the land to the atmosphere, getting into cloud formation, and then from clouds there is enough humidity, which we are going to discuss in detail, reaching dew point, then precipitation begins. The water is coming back again, run off to the ocean again, evaporate again, continuously like that, day in, day out, every month, every year. That is what we have. And that is what we call the adiabatic processes. The adiabatic processes. Therefore, examples of the adiabatic processes are, don't forget, after we discuss laws of thermodynamics, we are now going into our conduction, convection, radiation, advection, and so on. So you can see how each of these topics are connected together. Now, when we talk of the adiabatic process, we have conduction of heat that requires contact. One body and another body making contact. The heat transfer through this is known as conduction. It must be through a materials medium. So, conduction of heat through it must be at least two material media connecting together or in contact. But we have convection of it that involves hot air that rises from a surface of high temperature, rises to another surface of low temperature. That is conduction. Convection. That is what B. Then we have advection. Advection is when this, just like conduction, but this time horizontal movement. The horizontal movement of hot air. Don't forget that our air comprises of other gases, but principally nitrogen and oxygen, as we discussed. Don't let it leave that memory. So, when we have advection, it means that we are talking of horizontal movement of hot air from one body to another, or from one point to another, or from one environment to another. Then we have radiation. Radiation is the exchanges of heat through the space. What is the space? Space now can be from the ground surface to infinity, usually from our solar disk, which is the principal suppliers of our energy, the sun. So in between is the space. Then we have latent heat, which is the changing of phase. When water changes phase, water changing from solid, ice, air, for ice or in solid form, moving to liquid water, and then from liquid water changing to gaseous state. So we have latent heat. And this is the energy absorbed or released. It's either energy will be given or energy will be taken by the water during the change of its physical state or phase. We call it phase change or physical changes in the water without changing its temperature. Any question? of it from one body to the other through contact or touch. So the transfer of internal energy, U, by the microscopic collisions of particles. This we discussed using the water inside the glass cup last time, don't forget. Microscopic collisions of particles and movement of the electrons within the material or substance, which is called conduction of heat in the material. And this just to demonstrate hot moving to cold. The quantity of the rate of change of heat is QDT, the QT. And then here is just to demonstrate what is happening. Initial temperature plus change in temperature, that is the hot point, and then this is the initial temperature, the length of the block, the cross-sectional area A. So the thermal conductivity of the materials is defined as which is responsible to the amount of or the rate of which this heat is moving through the material. It's called thermal conductivity, which is K, and the unit is watts per meter Kelvin. Watt per meter Kelvin. Conduction, therefore, is the process of heat transfer from molecule to molecule. This now we are going back to our gas. Our principal interest is atmosphere containing gases. So now we define conduction of heat in terms of our interest, which is gas, gaseous state. So which is the transfer of heat from one molecule to the other molecule, from atom, talk of molecule. And then this energy transfer process require there must be contact, body contact. Here is, as we've known, for conductor of heat, therefore it has a very low thermal conductivity K. Note that the conduction is not an efficient mechanism to transfer heat in the atmosphere on a large spatial scale. Just to demonstrate the heat transfers. When you put your pot of water on the burner, from the burner to the room or to the environment is radiation, and then by the time it gets to the pot, the bottom of the pot gets heated, the molecules or the atoms of the water inside get excited, now change state from one point to the other, take energy, get mobile, and what happens? Move to the surface. The one that is at the surface with low temperature will now go down because it will be denser. The one at the surface is more dense than the one close to the source of the heat. The one close to the source of the heat is less dense. Hello? You want to ask a question? You are raising your, oh sorry, I thought you were asking a question. So, this is the processes. It will continue until the water now gets heated. And by the time the water boils, what happens? It will release to the environment, to the sky, or to the air, turning to gaseous state. So there is conduction between the handle of your pot and the pot itself, and then there is convection between the water molecules inside the pot as it gets heated from the base, and there are some radiations coming from the source of the heat, and before you know, the room also will get heated. Is there any ladies understand this faster? Okay. Now let's relate this into the atmosphere, into our environment, and this is what we have. Convection, as we have mentioned. The convection is the process of heat transfer due to bulk movement of molecules within fluids. Fluids can be gases or liquids, as well as molten, this my area, rocks, molten, when we have lava flow, that is rocks, solid rocks, turning to the liquid form far deep down beneath and then coming out, flowing. So, but usually maybe when we have eruptions, earthquake and so on. So, convection takes place through advection, as we have mentioned. They are interconnected. Advection is the horizontal movement, and then the vertical movement is convection, or through diffusion, or it could be through the two at the same time. So you can see that our surface, land or water or ocean, get heated, get warm via the energy released from the sun, and then what happens? Evaporation takes place. We have dry convection, and then we have move up, and when it go up, it's turned to the form of cloud. Okay. We also have other applications of the convection of heat. This is what is used for ship or boat, and this is natural convection, cloud forming, keeping buoyancy. But in our home, mostly we use microwave. So convection of heat is the phenomenon behind microwave that we use to warm our food, other things. Yeah, we also have particularly all the belief tutorial, all our lecture theaters or big buildings here, convo building. This is the process. The air conditioner is in one place. It can be used to heat or cool down the room. So, in this environment, is being used because we are in the tropic to cool down, to regulate the temperature of the room. Not only this also same the air conditioner, the same, only that the smaller one. This is the big one. So, this is the source. If it's to warm, it will send hot air, high temperature, and then go back again. The cold one come, but it replaces the cold one. That's to warm. If it is the other way, as we are using it to cool down the room, it will take the hot air and then circulate the cold one around the room. So this is the phenomenon of convection of heat, how it is being transferred from one point to the other. We now talk of advection, which is related to convection also. As we have seen, the warmer will move horizontally. Most or warmer here move horizontally across the surface of the ocean. Thereby, you have seen this kind of thing before. It formed a fog. The transport of a substance or material by bulk motion with the properties of that material being carried with it. It is horizontal transport of heat in the atmosphere. Advection can be considered as another form of convection. Just to give further illustration, the cold ground, colder ocean, warmer ocean surface, and then by the time the air passes through, what we have is fog. And this process is similar to that of the convection process, depends on the motion of the mass of transfer of heat from one place to the other. So I have enough examples on convection and advection. Now we move to radiation. Radiation, usually in our atmosphere or in our environment, it is the transmission of energy in the form of waves or particles through the space or through a material medium. It could be through the space or through material medium. Material medium, as we have seen in our cooker, putting our pot on it, as in the spaces between the sun and the land surface. Therefore, radiation is the heat transfer by emissions of electromagnetic waves which carry energy away from the emitting body of substances. And this is the principle we now use for transmitting messages, radio wave, video and audio combined to give television and so on and so forth. So electromagnetic radiation such as radio waves, microwaves, infrared, visible, ultraviolet, and so on. Then the solar energy moves through the empty space between the sun and the, which we have mentioned before. And the original source of our energy is from the sun. And this energy is the one that drives our weather and climate. The weather, I will talk, what is the weather? When there is a change in our physical environment pattern, and this change continuously for years, for decades, for centuries, now drive the climate. And this is the reason why we must study atmospheric thermodynamics so that we understand our environment as an environmentalist. So, how does the sun's heat energy reach you? How does it reach you? The sun, the energy that is coming from the sun. How? You said conduction? After you have listened to this? No, it's not radiation. Oh, this is what we just discussed. It's by radiation, and I've mentioned several times. So it's not by conduction. No, cannot. It's not by convection. Conduction means the body must touch. Can the sun touch your body? the physical disk impossible because of temperature. The temperature is too high. And then convection cannot. So it's by radiation, only by radiation. And this radiation, we call it electromagnetic waves. It can be particle in form of particles, it can also be in form of waves. Okay? So it's not by conduction.